Hello guys, good morning. So today we will be talking about exploratory data analysis. If you are working for any data science project, then exploratory data analysis is the most important step and it's the most time consuming step for any project. So today I will be taking you to the journey of exploratory data analysis step by step. I'll be explaining you each and everything, and it's not important that you follow all the steps as they come. You can take one step earlier and some steps are after that. So I will be starting with data sourcing. Data sourcing is the key component, like where you are getting the data from. If it is the data is public data or private data. By means public data, there are various government sites that are offering you data free of cost, and some of these data are already structured in a manner that you can do analysis directly picking up the data and doing analysis. And there are some data that you have to prepare the data before doing some analysis on that data. Okay, so this is the public data. And after the public data, I'll be talking about private data. Private data is the data owned by companies, and companies are reluctant to give this data as it is important for their business to grow, and they need this data to keep on moving in forward direction. So they have their data analysis team and everything. So these teams work on this data. Like if you see telecom industry, banking industry, retail industry, these are the data driven industry. They need the data, and once they have the data, they do analysis on this data. So we might not get hands on this data because it is a uh, high priority data for them. Okay, so after the day you get to know that you have the data, the second step would be data cleaning. Data cleaning is the most time consuming step in exploratory data analysis because you have to look at each and every data columns of features, like what they have and if there is something needs to be improved in that field. Okay, by means of data cleaning, I am telling you that in the data cleaning step, firstly you have to uh, there see all the rows and columns and see if there is anything to be fixed there. Like if there are some data in which there is a header also there and a footer also there, these things you don't need for data analysis purposes. So you can remove these rows, or there is a page number there, you can also remove such rows from the data. Next you have to look at the columns. Now by looking at the columns you can see that there might be a duplication of columns, like one column has the values and another column also has those values, but the column name is different. So you know that only one of the by using only one of the column you can get the data, so you can take that column only. Okay, the next step would be fixing missing value. Missing values are the values that are not present in the data. Suppose if you have some column and that column has around 50-60% of the values that are missing. By missing, I can say they can be NaN there or XX there, or there can be any constant value put up by the data engineering team. So these value are not varying. So when you will pick these values and do some analysis on this, these value will be treated as a constant, so they will not have any impact on the model. So it's not needed to keep these kind of features in your analysis part. Okay, then the third step would be standardizing the data. By standardizing, what I mean that there might be some numerical values that are high in ranges. Like if you have salary is something which can range from thousands to lakhs. And the second thing would be temperature. The second temperature can be ranging from 0 to 50 or 0 to 100, so like that. So when you compare these two things, one is on a high standard value, like it's from thousands to lakhs, and one is from 0 to 100. So when you compare these values, while preparing the model, these value will be treated differently and one will be having a greater impact. So what we can do, we can standardize these values, or and then there are also cases where the values might be 4000 and something labs. So if you can convert these values into one constant value, suppose your weight is having some of the values labs in labs and some of the value in pounds and some of the value in kgs. So you have to standardize these values. After the standardization is done, the next part is fixed invalid values. Suppose there are cases like you have a categorical feature which is having male, female, and transgender value, but some of the values that there are which are not explaining anything. Like it could be random, any random value. So you know that there can be only three type of genders like male, female, and transgender. So if there is any other value other than that, you can clearly say that these values are not valid. So you can remove these values from the data that you have. And also, like if I have a height feature with me and somebody is having height of 15 feet, so you know it's not possible, and you can see that these value are not explaining anything, and if you keep these value, it will impact your model in a bad way. So better to remove these kind of value. So by invalid values, I'm saying that the values that are not possible, but by typo, mistake, and anything, these values are there in the data. So you have to look closely into these values. So that's why it's a time-consuming process, because you have to look at each of the methods that I have telling you, like fixing rows and columns, then fixing missing values, then standardizing the values, and then fixing invalid values, and last and foremost is the filter data. By filter data, what I mean to say that uh, you can have the data. There are many duplicate values also there in the data. You can filter the rows that are that are having more number of null values. So you can remove only those rows that are having more number of null columns. Okay, then you can pick filter columns also, like duplicate columns are there, you can pick one. And suppose there is some column which is not important for your analysis purpose, like I can say if you have the data for for any employee and the information about their sports activity are given, then you know that this is not an relevant information for you. So you can remove this type of value, and then you can try to get the aggregate data also. Like there are multiple rows for some people, then you can maybe group by any column and then see the data how it is preparing. Like you can group by employee id, or you can group by order id, then you will have a aggregated data. So that will help you in a way, like when you don't have aggregated value, you have a large number of rows and the data gets increased. So if you have aggregated value, you have less number of data to get analysis on that. So if the data is less, then we can get a better opportunity out of that data. After the data cleaning part is done, the next thing is that you have the important features with you. Now you'll have to look into these features, what these features contain the value, and how you can see which is relevant and which is irrelevant. So the first step after doing the data cleaning part is univariate analysis. The name explains itself. Univariate means a single, taking a single feature at a time and then seeing what the value that feature is having. There can be an there are two type of categories, like you if you have the features that is with you, it can have order or unordered categorical variables. There are unordered categorical variables as well and ordered categorical variables as well. So like salary is can be high, low, and very low, this kind of thing. So this is an ordered variable. And then there is a month feature also, which is an ordered variable, like February is after January only. And if there is a class variable, then you know that first class is after the second class, and likewise. And there are unordered variable as well. For unordered variable, you can say that they can be loan category. Like if the loan is home loan, personal loan, you can't say set up a order in that. So these type of features are unordered. And then there can be the data can be for sales or marketing organization of a person. If is it a sales organization or a marketing organization, that is not a ordered category, it's a categorical value, but you can't set up a order in this. Okay, apart from this, you can also have some numbers with you. which are not ordered also, and not unordered also, like salary is a numerical value. You can use a numerical value, but you can't say that it's an ordered value or unordered value. It can be a discrete value, because salary can be discrete for many people. And also you can say that there are some variables that are having some only five or six type of value. So these are different variables, and then the discrete variables. For these categorical variables, you can set up some histogram or anything to do some univariate analysis. So by univariate analysis, I would like to say that univariate analysis is something which is done on the single variable. You pick a variable and draw insight from that variable if that variable is useful or not. If the variable seems to be useful, you can dig down deep and see if that variable is having some categories inside it. My means that I can give you one example. Like you can see the salary pattern, distribution of salary versus employees. Then you can pick up. There are four category in salary. Like there can be four groups of employees. And then you can pick each and every group and do the separate univariate analysis on this, and see if the mean value, median value, or mode value are changing for different categories for a univariate analysis. So once the univariate analysis is done, now you can see that we can do bivariate analysis, like one value is dependent on the other value. So for bivariate analysis, one concept comes very important, that is multicollinearity. Multicollinearity is something you can learn afterwards, but I can explain you that multicollinearity is something that one variable is explaining anything, and the other variable is also explaining the same thing. Then there is no need to keep those two variables. So the value of multicollinearity lies between -1 to 1. If the value is close to 1, then we can say there is a positive correlation. If the value is close to -1, then we can say the values are negatively correlated. And if it's 0, then we can say there is no correlation, and we can keep both the variables at the same time. By If I give you example of positive multicollinearity, we can say that if the rain is increasing, then the humidity will also increase. So it's a positive correlation. And for negative correlation, I can say that if the price of any product is decreasing, then the demand will increase. So this is a negative correlation. And the no correlation can be like, if I'm going to office tomorrow and will it rain tomorrow? There is no correlation between them. So we can say that these values are not correlated with each other. Okay, so after the bivariate analysis done, you can do multiple things within the bivariate analysis. Like you know that salary and occupation have some relation in between. So you can draw some graphs, like seeing that which category of employees are having more salary than the others. Okay, then you can if you have the data of suppose you have the data of your college information, like whose parents are educated and whose parents are not educated, then you can see that the salary of a educated person versus the salary of uneducated person. Then you can take one another variable, like marks of a student in science, and then you can see if his or her parents are educated or not. Then you can see if the pattern is there within all the states, or there is some uniqueness within some states. Like I mean to say that the marks of science students which have the educated parents in southern part of India are higher than in the northern part of India. So you can see that there is some difference in that. So the important part in doing this is that we have to find some patterns within the data. So this is one kind of pattern. Like you can say that more number of parents are educated in the southern part of India, and that's why the marks in science are more. Then you can say that less number of people, female parent is not educated in northern part of the India. That's why the marks of student in some subjects are less. I'm not saying that it's important, but by looking at the data, you can say that this is the pattern, and this is how, like the things are moving. So after doing this firstly we saw that the data source, what is the data source. After that we did the data cleaning part, and after this we did some bivariate and univariate analysis. You can do trivariate or multivariate analysis on that. Like I told you, like if you take the marks of a student in science subject for a particular state, then you can pick to the next category by taking one variable, like if his parents are educated or not, and then one more variable you can pick if the age of student is also taken into the analysis. After doing this, the next part is we can create some features out of ourselves. So there are three type of features that we can create, that are type driven, business driven, and data driven. So by means type driven, there are type driven features can be of four types. One can be nominal features. Nominal features can be there is a male female value, or there is a color value. If the colors are green, white, or yellow, then there is no order in between them, and these are the nominal features. Okay. After this there are ordinal features. Ordinal features are that marks, if marks are 50 and marks are 60, then you know that 60 is greater than 50. So you can set up some value that if the marks are greater than 50, then marks are above average. Then if marks are greater than 80, then you can set up that it's it's greater than 80, then it's the student is performing excellent. So by meaning that when you have the value, marks value, you have discrete value of that. Each and every student are having different marks, or some of them are having same marks. By doing this kind of analysis or converting some columns to another value, you can get a categorical output of this. Once you have the discrete value, and when you apply some function on it, that if the marks are greater than 50, then you put it as above average. Marks are greater than 80, then put it at excellent. Then in place of a discrete value, you have some nominal features that you can use in that place. Then also there is a interval variables also. Interval variables are like that you can pick if the temperature is between 30 and 40, you can set up that this is a low temperature, greater than 40 is a high temperature value. Or date, you can pick up date also, like if the date is between today and past 15 days, or the data you can pick up from today or past 30 days, like this. So date features and temperature features, they can be categorized into interval variables. So after that there can also be ratio variables. Ratio variables by means of that is that you know that marks are greater than 50, or if marks are greater than 70, then you can set up a ratio between them, that is 70% marks are greater than 50% mark, or something like that. And also there can be some metrics, like which is a business driven metrics. By business driven metrics, you can say that some business wants me to create a feature which is not present, but they want me to create it, so I can create that feature. Like I have a date feature with me, and business wants me to categorize the output into seasonal value. So yeah, I can make a feature like if the values are like the dates are lying between January and March, we can say that it's a winter season, like that. So business will give me the requirement, and I can create that feature by myself. Then after that there are data driven metrics also. By means of data driven metrics, you can see that for example, if I have a weight feature with me, and also the height feature with me, I can say that weight and height are both correlated. If the weight is more, then there is a chance that height would be more. uh, so in place of weight and height, I can create a new feature which is body mass index, and say that the body mass index of this person is greater than the other person. So in place of picking two correlated variable, I've made up a new variable, that is body mass index, and I can use that in the data analysis for that. So in this session, what we learned is that we have to first understand the domain which the data is there. We have to look at the data, if it's a public data, private data, and understand what is the data. So we have to look at the metadata of the data. If the data dictionary is given to us, we have to see what each and every feature is there and what it's explaining. and what is it necessary to keep or not. After that, we did some understanding of the data and preparing it for analysis by doing data cleaning and filtering the data, aggregating the data. After that, we did univariate and bivariate analysis on the data to see if the data is having relevant values or irrelevant value. If the data is not having relevant value, we can remove those features out of our analysis. And then we at last we derived metrics. By deriving metrics, we saw that there can be data driven metrics, business driven metric, and also type driven metrics. So if you are doing an data science project, then this is the most important part, because if you don't have a data which is good to go, then you can make a model can be made by any of the data, but it is important that the difference between the good model and an average model would be exploratory data analysis only. Because if I am doing some exploratory data analysis into detail, and I'm finding some interesting pattern and using those pattern into my analysis, and if you are not doing that, then your model will give an output, and my model will also give me an output. But the difference lies like in that how we prepared the data for the analysis. So this much for today, and if you have any doubts, do contact me. Yeah, thank you. Have a nice day.